In this video, we're going to move on from expressions to equations. The key difference is that now we see an equal sign. Usually in our equation, we're going to have a variable, and our goal is going to be to figure out what the value of that variable is to make both sides of the equation equal. In order to do that, we're going to use what we call inverse operations. Operations are addition, subtraction, division, and multiplication. Inverse means opposite. Each operation has an inverse operation. So addition and subtraction go together. If you add something, you can undo that by taking the same amount away. Multiplication and division also go together. If you divide by a number, you can undo that by multiplying by the same number. So when we look at these equations, we're going to always start by circling our variable. Ooh, I'm a little crazy there. We're going to start by circling our variable, and then we look at what's outside that circle. Here outside the circle we see plus 9, and we want to undo that, so we are going to do minus 9. Now we want to think about a seesaw. If you have two things that weigh exactly the same, that seesaw is balanced, and we want to always maintain balance. So if I subtract 9 on the left, I also need to subtract 9 on the right. So now I subtract 9 from both sides. My y is going to come down. 9 minus 9 is 0, so now we've gotten rid of this, which is what we wanted to do. We wanted to get the variable alone. And negative 12 minus 9 is negative 21. We can check to see whether our answer is correct by substituting it back into the original equation and seeing if we get the number on the other side. So negative 21 plus 9 is negative 12. That's equal to negative 12, so we know that we did this correctly. Go ahead and pause the video and try the other equation. Alright, so for this one, again we circle our variable. We see minus 7, so we're going to do plus 7. We add 7 to both sides, and these cancel each other out to 0, so we don't need to write plus 0. And then on this side, negative 10 plus 7 is negative 3. If we want to check our answer, we substitute it in for x, copy everything else down exactly the same, and do the math, and we get negative 10 on both sides, so we know that that is correct. These are both examples of the additive inverse property. Additive, again, referring to addition, inverse meaning opposite. We do the opposite of what we see. For these examples, remember that a fraction represents division, so the opposite of division is multiplication. So here, to undo division by 6, we're going to multiply by 6. And again, whatever I do on the left, I must do on the right. If we think about 6 as 6 over 1, these will cancel each other out to a factor of 1, and we're just left with x. On the right-hand side, 5 times 6 is 30, so we end up with an answer of 30. If we want to check our answer, we substitute it back in. 30 divided by 6 is 5, so 5 equals 5. Here we have multiplication. The opposite of multiplication is division. So I'm going to divide both sides by 4. 4 divided by 4 is 1, so that just leaves us 1x, which is what we want. And then 12 divided by 4 is 3. If we want to check our answer, we can substitute in 3. And if I do 4 times 3, I get 12, which is the answer that we wanted. Remember that whatever we do on one side, we must do to the other side. Same on both sides. We want to keep that idea of balance. So, if we look at this example here, we have y plus 9 equals negative 12. I'm going to start by circling my variable, and I look outside the circle, I see plus 9. So the opposite of plus 9 is minus 9. We do that. Some people like to draw a line down the middle here so we can see both sides. Then 9 minus 9 is 0. That leaves us just with y. That's equal to negative 12 minus 9, which is negative 21. To check our answer, we can substitute negative 21 in for y and solve. Negative 21 plus 9 is negative 12, so negative 12 is equal to negative 12. For this example, again, remember the fraction represents division. So we're going to undo that division with multiplication by 5 on both sides. These 5's cancel each other out, so we're left with x equals negative 30. In order to check, we'd have negative 30 over 5 equals negative 6, and that gives us -6, which is equal to -6, so we know we did it correctly. Go ahead and pause the video and try the other two examples. In our example up top, just because the variable side and the plain number side have switched locations, that doesn't mean we're going to do anything differently to solve it. I still see subtraction, I undo that with addition. I get an answer of -3. In the bottom corner, remember that any time the number is right next to the variable when we have a coefficient, that means that we're multiplying. So we need to undo multiplication with division, and we get an answer of -15. Now we're going to look at equations that are a little more complex, but the idea remains the same. We're still going to always do the opposite of what we see. I'm going to start by circling my variable term. Outside the circle, I see -4. So the opposite of subtraction is addition. So I'm going to add 4 on both sides. -4 plus 4 is 0, so now I don't need to worry about these terms. All that's left on this side is 8x. On the right side, we have 12 plus 4, which is 16. Now, I know that when the 8 is right next to the x when it's the coefficient, this is multiplication. The inverse of multiplication is division. So I'm going to divide both sides by 8. This cancels out to just 1, and 16 over 8 is 2. So my answer is x plus 2. For this next example, I'm going to circle my variable term, and remember that when we talked about coefficients, we talked about including the sign in front of the number. So I'm going to make sure that I circle this negative sign in front of the 4. Now, outside the circle, I see a +6. In order to get rid of that 6 and make it 0, I'm going to subtract 6 from both sides. All that's left now is what's in the circle, -4x, and then on the other side, we have 36. Now, again, we know that a coefficient is always multiplied by its variable, so we divide both sides by -4. -4 over -4 is 1, and x equals -9. Remember that our strategy doesn't change if the side with the constant switches with the side with the variable. So, if we look at this example here, we're going to follow the same approach. I'm going to circle my variable term and start outside the circle. I'm going to subtract 4 from both sides to undo the addition, and 4 minus 4 is 0. All that's left on the left-hand side is, or on the right-hand side is -x, and on the left we have -7. Now, I remember from dealing with expressions that when there's no number there, it's equivalent to having a 1, and if there's a negative sign in front, it's the same thing as -1. The coefficient is always multiplied by the variable, so I'm going to undo that multiplication with division by -1 on both sides. -1 divided by -1 is +1, so on the right, all I have is x. On the left side, I get 7 as my final answer. Go ahead and pause the video and try the last equation on your own. In this example, we get 2 as our answer. Again, we circle our variable group, and then we want to get rid of the constant. We're always going to remove the constant via addition or subtraction. Here, we have +3, and in order to get rid of that, we're going to subtract 3 to make 0. We do that on both sides, and then we have to undo the multiplication, and we get 2 as our answer. These are a little different than what you might normally see, but our process still remains the same. In our first example, I'm going to circle my variable group. I see that we're doing addition, so I'm going to undo that by subtracting the exact same number as we were adding. So now, -7 minus -7 is 0. Remember that any number minus itself is equal to 0. On the left, we're left with x, and on the right, -77 minus -7 is -70. You will be able to use a calculator, so don't get too worried if you're still having a hard time with the positive and negative numbers. Now, anytime we see a fraction as a coefficient, we're going to do a little bit of simplifying first. Remember that I can make any number a fraction by putting a 1 in the denominator, and then we multiply horizontally to put everything together. 1 times x is x, 2 times 1 is 2, and now we have a fraction that looks like division, and this looks a little similar to what we were doing before. I see division by 2, so the opposite of that is multiplication by 2. 2 times 2 is 1, so I'm left with x, and on the other side now we have 8 as our final answer.